Abaqus Club. In this video we are going to talk about the other sections in Abaqus like property, assembly, step interaction, load, mesh, and how to run a process. So in the last video I did talk about the part designing and how to design different parts for a process. So we are going to continue with knowing how to work with the other sections. So let's go to the property, but I would like to actually explain this the other sections into simulating a very simple process like drawing. So in drawing we have we have a wire which is gonna be drawn from into the die to reduce uh, its uh, diameter. And I will show you how to simulate this drawing. So first of all we need to know I'm gonna show you a schematic of drawing. So as you can see, this is a schematic of drawing. In the drawing we have a wire which is a cylinder shape, and it's gonna draw it into a die. So because of this we can assume the process as a asymmetric, like a 2D process, 2D simulation, and after the simulation is being finished we can extend this to the whole uh, body of the cylinder. So I will show you how to do this. So let's go to the Abaqus. For this we need to design a die and the wire, the actually the section of the wire. So click on create a part, name it as a die, an asymmetric. Die is not deformable, it's rigid, and it's a wire, and assume this is 1. So continue. I'm gonna in asymmetric it is very important to draw your uh, design on one side of the asymmetric, because the asymmetric is like this, and after that we're gonna like extend it along this axis. So like this I'm gonna like dimension it. So this would be 0.01, and I'm gonna make a fillet between two 0.002 between this and this, and also this and this. And the reduction, this is very important, this is between here and here, because it's our reduction. For example, if this be the diameter be 20 millimeter and we can apply 30% reduction, we have to calculate how much the diameter decrease, and this is the radius, not the diameter, from here to here. So it's gonna rotate along this axis. So the the radius of this die is, I mean, from here to here, it is 0.00922, and the angle of this is called angle of the die. So it can be here or here or even here. But how to make an angle, like here, click on here and click on this, So from here to here would be 180, and if we want to from here to here be 30, we just need to consider this as a 150, like this. So this is 30. So yeah, this is our die, and by clicking here and done, you will see. And now we are gonna uh, draw the section of our wire. So we'll name it as a wire, asymmetric, deformable, shall continue. And the dimension of this section is, for the height is 0.05, and here is 0.01. So by clicking here and here, you will see this is the section, like this. So after this, we need to go to the property section, and in property we need to apply a proper property to the deformable parts. We don't need to apply property to the rigid, because rigid is rigid, so it's assumed not to be deformed. So I'll choose the wire, and by clicking here, first of all we need to create a material, and after that apply that material by creating a section, and apply that section to the material. So the picture is already shown. So by clicking on create a material, I'll name this as, I'll choose the copper. So you can also Google the property of the copper, but here I only add the density, add the elastic property, and the plastic property. You can also, if you had another process for the drawing, we just need to like apply the density, define the density and the elastic part and the plastic part. So we already know it's the density is 8,960, and the elastic, the Young model, these are on internet, so you can download it or just follow as I'm entering. 133E9, and here 0.35. And in the plastic, this is also in internet, in a pure copper, yield stress and plastic strain. I already downloaded. This is the this is the stress and this is the strain. So I'll copy this and paste it here, or you can pause the video and enter these numbers. So it starts with 0 and with 0.219, and yeah. So by clicking OK, you can see this material is created, and we just need to click here to create a section, homogeneous one, and continue. Yeah, this material, copper, you already made it. OK, and apply this section by assign this section, or apply this section, I don't want to set, to this material. I need to choose to this part. I need to choose this part. Look, it should be like this. I'm clicking on done. Yeah, I want to assign the section 1. I'm clicking on OK. You can see the color changed. And after property, I need to go to the assembly. This is a very important thing, because we need to assemble the process. Before that, we need to enter our two parts we already designed. And you can also see there is a option here. If for example this part be here, I mean the interaction between these two, by choosing here, it's the auto offset from the instance will be activated, and you can like move after the you enter these two parts, you can move the parts in a proper position. But it's already not in contact to each other, so I don't need to use this. And you also can see two option here, dependent and independent. Uh, these two options is related to the mesh, actually. Dependent mesh on part and independent mesh on an instance. Mesh on an instance means you can if you choose this one after the assembly and going here into the mesh, you have to mesh the whole process together. You cannot, for example, choose this one separately or individually and this one individually. But if you choose this one, you can just separately mesh it. So I'll choose this one and clicking on OK. So here you can see the parts are entered. So uh, fix we need to fix this two parts in a proper positions. And what are these? For example, this process says I want to apply a pressure here, which gonna draw this section through this die, but at least it should be a little bit closer. So for this there are many options here, but I'm gonna only I will explain these things in the next in a proper process. But here you just need to know how translate instance work. The translate instance is an option for moving the parts that you already entered here. For example, if I want to move this along this, be be keep this in mind. You can only move these two on this side of this axis, because the process, the simulation is asymmetric. And by choosing this translate instance, you can move this along here or here until this, or even this one. So for a better understanding, I'll explain you by translate the die. So I'll choose this one and uh, select the die and clicking on done. And I have to choose a point for moving. For example, I want to fix this point, yeah. The, and this movement is based on this axis. So this is 0, 0, 0, and from here to here was 0. If you remember, it was 0.00922. So if I choose the x as the y as 0, this set, set r and t, set as 0, and choose the r as 0 point 00922. Sorry, yeah, I need to choose the point and choose y as 0, and this one 0.00922. Sorry. And pushing the scroll, you can see this point came to here actually, so it moved. Now I can move this one, yeah, by clicking OK. So by clicking here and choosing this, and now I can move, I can translate this point by clicking on this point. You just need to enter the proper coordinate. So this coordinate is 0, is 0.00922 and 0. And I wanna make a little bit gap between this surface and here. So I'll choose the same, but I have to keep in mind the distance between here and here is 0.01. So this is the distance we already, because we already designed 0.01. So, and the height would be 0.0, for example 0.5. So you can see it came closer. And okay, so this is how translators work. So after the assembly, we need we go to the step. In a step, we are going to define the steps, the steps into the process. So in a step, we need to know the process is gonna we are going to divide the process into the necessary steps. For example, here in drawing there would be only one step, because we just need in one step draw this section into this uh, die. But for example, in a rolling, we need one step for grabbing happen, and another step for the rotation of the rollers, and it depends on the how many stages does this uh, process have. We need to think about how many steps should we define. But right now here the process is very simple and we only need one step. And by clicking here create a step, you can see the different kind of steps. For example, static general and dynamic explicit, dynamic implicit. So the static, as you can understand from the name of this step, it's for static processes, but this process is not static, it's dynamic, and it's also explicit, because the deformation is too much here, like 30% reduction or 50% reduction. So I'll choose this one, dynamic explicit, and clicking on continue. And here you can see the time period, so it means that how many seconds or how long is gonna take this process. So for example, in reality this process might take 5 seconds, 3 seconds, 4 seconds, or 10 seconds, or whatever, but here I let it be in 1 second, just because this is just a testing. So keep in mind these time period should consider as a reality in a real simulation. So just leave these other three these three sections here, just leave it. I will explain this in the next in the like other videos, but this video is only for a very beginner students who just want to know how Abaqus works. So consider the time period as a 1 and click on OK. So you can see one step is created. So after a step, go to the interaction. In interaction, from the name it's obvious, we need to define the interaction, the connection, the interaction between the surfaces. For example, this surface of this wire has a connect between this surface and this surface. So first of all, we need to create a surface. Here in assembly, by clicking on this plus, you can see the surface. Right click on it and click on create. The surface one, I'll name it die, because I'm gonna choose the die surfaces which is in contact, and clicking on continue. I'll choose this one. Hold the shift on your keyboard and click here, and also remember to click here too, so because it's all is in contact. By clicking on done, and it asks you which side of this lines, so I'll choose the yellow because yellow is in contact. And after that I need to create another surface, which is the surface of our section. So I'll name it wire, clicking on continue. So this surface is in contact. You can also choose this surface, but it doesn't make any like changes, but this surface is already enough. So click on done. So you can see two surfaces are created. And after that, we need to create a property for our interaction. So for example, what kind of interaction is this? By clicking here, the name of the interaction property is optional, but this type of interaction is not optional. You have to know what is the type of the interaction. This interaction is in the contact interaction, not thermal or cavity or whatever. So it's only contact. So by clicking on continue, you will see this window. In this window, as I said, it's not electrical or thermal, it's mechanical contact between these two surfaces. And it's tangential behavior, or damping, damage, or fracture, cohesive, or geometric properties. It's not damage, it's not damping. I'll choose only tangential behavior, and you can see I can leave it on frictionless. It means I ignore the friction between these two surfaces, or I can choose a penalty one. It means a specific coefficient. So the friction coefficient would be, I'll consider it 0. For example 5. This is just an example. You have to be sure what is the friction coefficient between the surface of your die and the copper. So I'll choose it just randomly as a 0.5. By clicking on OK, the material the interaction property is created, and now we should apply this. Sorry, we need to apply this interaction between these two surfaces. By clicking here, create interaction, and you can see the step. You can choose initial from the initial or from the step 1. In the initial there is no contact, so I'll leave it be the step 1, because in step 1 there would be a movement here, so I'll let it be in step 1. And this type of interaction is surface to surface contact, explicit. This is explicit because our step is explicit. So clicking on continue, you can see the surfaces here. I will click here, and the first surface is the surface of the die, and the second surface, I'll click here, I'll choose the surface of wire. So you can see the first surface, the second surface, and this is our interaction property. By clicking OK, you can see the interaction is applied. So the next section would be load or boundary condition. In the load or boundary condition, we need to define the condition of our process. So in this process, the wire is going to be drawn into this die by drawing pressure from here, and this die should be considered as a fixed die, not any movement. So first of all, how to fix this die? So how to fix this die? Before that, I need to mention another things. If you go back to the part section, I forgot to tell you, for the rigid parts, always you need to define a reference point. The reference point is a point that you can apply any boundary condition on this point, and after that it's considered as it applied to the whole body. It would be much more easier. By clicking on here on tools, you can see the reference point. It doesn't matter which point you're gonna choose, it's really not important. I'll choose here, for example, and I'll go back to the load, so you can see the reference point here. By clicking on creating a boundary condition, you can see from the initial, not from the step 1, I'll choose this symmetry, asymmetry, and clicking on continue and choosing this reference point and clicking on done. You can see there are lots of options here. If you choose this option, it's gonna fix along the whole directions, even rotations. U1, this is U1, U2. All I can explain it here. Yeah, U1, U2, and U3. And UR1 means rotating around the axis 1, or UR2 means around the axis 2. So I'll fix it in the whole directions. I don't want this die move at all, and you can see. So, and the other thing is to uh, choose a displacement, but it's important to choose from here, because not from here, because in the drawing the pressure is from this side. So by clicking again here, you can see the displacement rotation, and in step 1 you can also name it wire movement, for example, by clicking on continue and choosing only, not the whole, only this surface. So you can see it's gonna be red, and clicking on done. So you can see U1, U2, because this is asymmetric, U1 and U2 and UR3. So it's gonna rotate, for example, like this. But we are not gonna rotate it, we are gonna move it along the U2, this direction, but minus U2, because the direction is opposite to this direction, to this direction. So I'll click here, and how much, this is very important. We already know distance from here to here is 0.05, and the distance between here to here is 0.01, and also we made a gap between here to here in 0.005. So the add of all of these number would be 0.065, but I'm gonna make it, for example, 0.08. I just want to make sure, be sure that this wire gonna pass from this tire, and it would be minus actually. And also in the explicit, the software asks you amplitude. What is the amplitude? If you click here, you can see. I'm gonna explain you in the table. So just choose the toolbar and amp1. So you will see here the time frequency and the amplitude. Our time in the step was 1 second. So the beginning will start with 0, and there would be no pressure or no force here. So the amplitude would be 0. But in the time 1, it would be 1. What is this 1 meaning? This 1 means 100% of the whole uh, force that we are applying. So for example, this would be a figure of 0, 0 and 1, 1. By clicking here and choose this amp1, after that continue, you will see the direction of the movement here also. So this would be a boundary condition, and you just need to mesh. So you can see you cannot mesh on assembly on the whole instance, you need to mesh on the part. So here in the mesh, as you already know, because you choose the dependent in the assembly, you can mesh the mesh each part separately. So here I'll choose the wire as a deformable part, and the most important things here is seeding the lines and choosing the mesh control. So if I click here, you can see three colors. So the free, structured, and sweep. The structure is the best mesh as I know. The quad dominate structure is the best mesh for the processes. So but also it depends on the different kind of process, and I'll explain the sweep for example in the rolling maybe later. But choose the structure, and if you choose that and click on OK, you can see the color is also changed. And now it's important to choose the seeds. As you know, the distance between here and here is 0.05, but you can like divide this line into the number of seeds you want. So if I choose 0.005 and click on apply, you can see the number of seeds that made here. And if I want to decrease the size of mesh, I'll decrease this number, for example 0.001, and clicking on apply, you can see the number of the mesh is increased. So by clicking on OK and clicking on mesh part, and yes, you can see the mesh is applied to this uh, part. You can also change the mesh size, for example, by decreasing 0, for example 8, clicking on apply. You have to click here delete the meshes because this mesh is not valid anymore, and clicking on OK and clicking here, you can see it decreased the size of mesh. And also you need to mesh the die. I'll choose the same options by just clicking here, and here you will see the mesh is already assigned. So the last section you have to do is the create a job. Go to the section of the create a job. Here by create a job, you can name your job whatever you want. I'll for example I'll choose it drawing, and clicking on continue or draw whatever, and clicking on OK. And after that, by clicking on job manager, you will see here there is a button that is called submit. If you click on submit, the simulation process will start. So by clicking here, yeah, before clicking I'm gonna tell you something which is important. If you click on file, and you can see the set work directory, the result of the simulation is gonna save here into the add. If you click there, you will see it's gonna save into this direction. You can also change the direction of save. Because I already had a result of drawing, you can see it gave me. And are you sure you want to like apply this um, job on that drawing? So I'm not sure, I don't want to do that, but I'm going to change it by clicking set work directory and change the direction of the, for example here, to the ODB. Okay, so yeah, ODB, clicking OK, and you can just submit. So after the simulation is being finished, you can see the complete status here, and you can check the result by clicking result here or go directly to the visualization. So you can see the result, for example by clicking here, you will see how it is decreased, the reduction is applied to this drawing. Or by clicking here, you can see the simulation animation. Or even if you click here, animate time history, you will see it's playing the animate, how this drawing is worked. So I'm gonna I also want to show you something which is very interesting. I already told you, if you just need to consider this section and then extend this section into this model. So I'm going to show you how we are going to extend this section to the model, or better to say, how to see the whole drawing, not like asymmetric. So by clicking on view and going to the ODB displays option and into sweep extrude, this is for the element, and this is for the rigid part. The rigid part is a die, and the element is the our deformable section. By clicking here, it says how into what degree you want to rotate this section. 180, it means half of the circle, and 360, it means a complete circle. So I'll choose the 180 to see a section of our uh, um, process, and I also want to increase the number of segments, so for example to 50. And I also choose the 180 degree of rotation for the die. So increase the segment, click on apply, you can see, yeah, it is rotate like this. So you can see, so now by clicking OK, you can see it's gonna, this is the uh, drawing process. So this is because the pressure is from here, and the uh, movement of the material is along this direction. So yeah, so this was a video of a very simple simulation. I hope you enjoy, and good luck.